Hi students, today discuss XII 6.5, one problem. The first question, find the parametric form of vector equation and a Cartesian equation of a straight line passing through the point 5, 2, 8 and is perpendicular to the straight lines r vector equal to I vector plus j vector plus k vector plus s of 2i vector minus 2j vector plus k vector and r vector equal to 2i vector minus j vector minus 3k vector plus t of I vector plus 2j vector plus 2k vector. Now find parametric form of vector equation and Cartesian equation of a straight line passing through given one point. Passing through one point, we want one parallel. So, and is perpendicular to the straight line. Given two lines is perpendicular to the straight lines. R vector equal to this one is the point is A. R vector equal to A vector plus S of B vector. That is a parallel line. That is a parallel. That is a P vector is a direction, one of the direction. And the second line is R vector equal to C vector. That is the point is C vector plus T of D vector. T of D vector. That is a parallel of B vector and D vector. And it's perpendicular to the straight line. Perpendicular is a perpendicular to the straight line means that is a perpendicular or B vector cross D vector is perpendicular to A and B. Given it is a one of the line, that is the first line is this one and the second line is this one, that is the direction is B vector and this direction is D vector. The first one of the line is the direction is B vector is this one and given the line is the direction is that is a D vector. Now find the perpendicular to. Perpendicular line is this line is perpendicular. That is a perpendicular line is B vector cross D vector. That is a perpendicular line is B vector cross D vector. Now find the perpendicular vector is B cross D. Now find B vector cross D vector. That is a perpendicular. So now find the perpendicular. Given a B vector is, that is a B vector equal to 2i vector, that is the direction. P vector is 2i vector minus 2j vector plus k vector. This is a B vector. And D vector is this one. D vector equal I vector plus 2j vector plus 2k vector. This is a B vector is 2i minus 2j plus k and D vector is this one. I vector plus 2j plus 2k. Now find perpendicular vector. Perpendicular is B vector cross D vector. Now find B vector cross D vector equal to, that is a B cross D is vector product of two vectors. Vector product of two vectors by using determinant form. Determinant of I vector, j vector, k vector. The component of B is 2, minus 2, 1 and the component of D is 1, 2, 2. Now expanding the determinant. I vector into this one, this is a minor matrix, minus 2 into 2, minus 4, form is minus 2 ones are 2. Next one, taking the element minus j vector into, taking the elements 2 2s are 4 and minus 1 into 1, 1. Next one plus k vector into, taking the element k, getting a minor matrix this one, 2 2s are 4, form is minus 1 into minus 2, already formula is minus half minus plus 2. That is a vector is minus 4 minus 2 minus 6 I vector 4 minus 1 3 plus 3 already outside minus into plus is minus 3j vector. Next one 4 plus 2 6 plus 6k vector is B vector cross D vector. That is a B vector cross D vector, that is a perpendicular line. Already now find the parametric form of vector equation, vector and Cartesian equation. The plane passing through the given one point and parallel to the straight line. And parallel, one point and one parallel, find the equation of vector and Cartesian equation. First now find vector form of a straight line. R vector equal to given one point is A vector plus S of B vector, where B vector is the parallel, that is the direction. Given B vector cross D vector is a perpendicular to the B vector and D vector, where B cross D is a parallel, lines. This is B cross D is parallel. Therefore, B vector cross D vector is parallel. B cross D is parallel vector. That is a parallel vector of parallel vector. So, B vector cross D vector is a parallel. Already one point is given. The one point is 5, 2, 8 is 1 point. And B vector cross D vector is parallel vector. That is a parallel vector is parallel vector minus 6i vector minus 3j vector plus 6k vector. Parallel vector. Already one point is given. One point is 5, 2, 8. Given one point and one parallel, find the equation of vector and Cartesian equation. Now find vector and Cartesian equation, the plane passing through one point and one parallel. Given the passing through the point is 5, 2, 8. That is the point A of 5, 2, 8 is the point, and the parallel vector is, that is a B vector equal to, now taking the point B vector equal to minus 6i vector minus 3j vector plus 6k vector. That is the point is A vector. Therefore, A vector equal to, that is A vector equal to 5i vector plus 2j vector plus 8k vector is the one of the point. One point and one parallel. One point and one parallel. Find the equation of straight line in parametric form. In parametric form. First one, now find the parametric form of vector equation. This parametric form is R vector equal to A vector plus S of B vector is the parametric form of vector equation. That is R vector, now substitute R vector equal to, here A vector is this one, 5i vector, it passes through the point, 5i vector plus 2j vector plus 8k vector, that is a point, plus S of B vector, that is a B vector is minus 6i vector, minus 6i minus 3j plus 6k vector. That is a point, one point and one parallel, parametric form of vector equation. Next to find Cartesian equation. Next equation, Cartesian form. The Cartesian form is, already you know Cartesian form, one point and one parallel is x minus x1 by b1, y minus y1 by b2 and z minus z1 by b3. This is a Cartesian form. X minus x1 by b1 equal y minus y1 by b2 equal z minus z1 by b3. That is a Cartesian form. Here find this x1, y1, z1 equal to, given the point, that is the point is 5, 2, 8 and b1, b2, b3 is b1, b2, b3, the point is minus 6, minus 3, 6. Now substitute the point, that is implying the Cartesian form is x minus 5 by b1 is minus 6 equal. Next one, y minus y1, y minus 2 by b2 value minus 3, it is minus 3 equal z minus 8 by b3 value 6, that is here Cartesian form of a straight line. Okay students, exercise 6.5 over. The next one topic, different forms of equation of a plane. Different forms of equation of a plane. The first one, equation of a plane when a normal to the plane and the distance of the plane from the origin are given. Equation of a plane when a normal to the plane and the distance of the plane from the origin are given. What is given? That is a normal. What is a normal? Normal means a straight line is, that is a straight line. It is a plane. A straight line is perpendicular to the plane. A straight line is a straight line, that is a straight line. The straight line is perpendicular to the plane, then it is called a normal. That is a normal means a straight line is perpendicular to the plane, that is called a normal. So find the equation of the plane. Find the equation of the plane when a normal to the plane and the distance of the plane from the origin are given. What is given? Normal and distance of the plane from the origin are given. Find the equation of the plane. So what is given? Normal and distance is given. that is a plane. That is a plane. First one given normal to the plane is that is the point is O. Normal to the plane is the straight line is perpendicular to the plane. That is a perpendicular to the plane is a normal. That is this one is normal. Now called the normal vector is d cap. D cap is a unit normal vector. D cap means D vector is a normal vector. D cap is unit normal vector. This one normal vector. The next one given the distance of the plane. The distance of the plane from the origin are given. The distance between origin to the plane. The distance between origin and the plane is P. The distance between origin and the plane is P. That is the point is P. The next one, let P be any point on the plane. Let P be, this is the point is P, where P is any point on the plane. Now OP, that is right here, OP vector equal to, now write in OP vector equal to R vector. OP vector equal to R vector. Now find the equation of a plane. Find the equation of the plane. Equation of the plane is two types. First one is vector form and next one is Cartesian form. The first one is vector form. First one vector form. What is given? First one is unit normal vector and the distance is given. Unit normal and distance is given. Unit normal vector is that is unit normal vector is d cap. D cap is unit normal vector. And the next one distance equal to P. This is a distance equal to P. Therefore the vector equation of plane, the normal vector is d cap and the distance from the origin to the plane is P vector. Now find the vector form is, that is a vector form equal to R vector dot d cap equal to P. That is a vector form is R vector dot d cap equal to P. That is a vector form. Where d cap is a unit normal vector. Now write in a d cap equal to unit normal vector is, now write in d vector by modulus of d vector. That is a d cap is a unit normal vector. D cap equal to d vector by modulus of d vector. That is a unit normal vector. First now write in a, that is a vector form. The next one, the distance between the length of perpendicular from the origin to the plane is the length of, therefore the length of perpendicular from the origin to the plane is, write in the formula, the length of perpendicular from the origin to the plane equal to P by modulus of d vector. P by modulus of d vector. That is the length of perpendicular from the origin to the plane. The length is perpendicular from the origin to the plane is using formula P by modulus of d vector, where P is already distance is given. P by modulus of d. D is a unit vector. Now find magnitude. It is a d vector. Modulus of d vector. The length of perpendicular from the origin to the plane is P by modulus of d vector. The next one, equation of a plane perpendicular to a vector and passing through a given point. Find the equation of plane perpendicular to a vector and passing through given one point. Now find the equation of the plane given one point and one perpendicular. That is a plane. This is the origin is O. Let A be any point on the plane. Let given a one point. Let A be any point on the plane. Let OA vector equal to A vector. OA vector equal to A vector. Let P be any point on the plane. Let OP equal to R vector. OP vector equal to R vector. Next one, perpendicular to a vector. Perpendicular means a straight line is perpendicular to the plane is, that is a normal, that is a perpendicular vector is n vector. N vector is a perpendicular vector. Now find the equation of the plane in vector form. Now write me a vector form. The vector form. Vector form is R vector equal to r vector or a vector. So r vector dot n vector equal to, that is a vector form is r vector dot n vector equal to a vector dot n vector. The r vector dot n vector equal to a vector dot n vector is a vector form of equation of a plane. That is a plane equation. What is given? One point and that is a b, a one point and perpendicular. A point and a perpendicular is given. Equation of a plane in vector form is r vector dot n vector equal to a vector dot n vector. Now discuss exercise 6.6 problem. First one, find the parametric form of vector equation of a plane which is at a distance of 7 units from the origin, having 3, minus 4, 5 as a direction ratio of a normal to it. Find the parametric form of vector equation of a plane. Find the equation of a plane in vector form. Distance and direction ratio is given. Distance and direction ratio is given. Find the equation of a plane. Already you know equation of a plane. One point and or normal and distance is given. Normal vector and distance is given. Now find the equation of plane in vector form is r vector dot d cap equal to p, where p is the distance. P is the distance between the origin to the plane. The next one, unit normal vector is d cap is the unit normal vector. That is a normal vector is d vector is a normal vector. D vector equal to normal vector. Now find the equation of a plane. Distance and normal vector is given. Find the equation of the plane. Now first find in a parametric form of vector equation. Parametric form in vector equation is, that is a vector form. What is given? Distance is given. Distance p equal to 7 units. Distance is 7 units. And my 3, minus 4, 5 as direction ratio of normal. That is d vector equal to, that is a normal vector. D vector equal to, now write in a vector form, 3i vector minus 4j vector plus 5k vector is normal vector. Now write in a vector form, parametric form of vector equation, vector form r vector dot d cap equal to p. R vector dot d cap equal to p. Already you know d cap is d vector by modulus of d vector. That is a unit normal vector. Now write in r vector dot d cap. D cap is, already you know, d cap equal to d vector by modulus of d vector. Now write in d vector is this one, d vector by modulus of d. 3i vector minus 4j vector plus 5k vector divide by modulus of d vector. Modulus of d vector means square root of square the value. Square root of square this value. 3 square is 9 plus minus 4 square is plus 16 plus 5 square is 25 equal to, where p is the distance is 7. Distance is 7. The next one, r vector dot 3i vector minus 4j vector plus 5k vector is divided by root of 9 plus 16, 25. 25 plus 25, root 50. Root 50, now write in 25 into 2, 5 root 2. This 5 root 2 equal to 7. That is a r vector dot 3i vector minus 4j plus 5k. Now write in r vector dot 3i vector minus 4j vector plus 5k vector. 5 root 2 that side. 7 into 5, 35 root 2. 35 root 2, that is a parametric form of vector equation of the plane. In second problem, find the direction cosines of the normal to the plane 12x plus 3y minus 4z equal to 65. Also find the parametric form of vector equation of a plane and the length of the perpendicular to the plane from the origin. Now find the direction cosines of the normal to the plane 12x plus 3y minus 4z equal to 65. Already equation of the plane is given. Now find the direction cosines of the plane. Also find the parametric form of vector equation to the plane and the length of perpendicular from the origin to the plane. Given the equation of the plane is 12x plus 3y minus 4z equal to 65. 12x plus 3y minus 4z equal to 65 is the equation of the plane. Now writing the equation of plane in a vector form is r vector dot 12i vector plus 3j vector minus 4k vector equal to 65 is a equation of plane in vector form. Equation of plane in vector form. Let r vector equal to xi plus yj plus zk. Now substitute this one xi plus yj plus zk. Next now find dot product of two vectors is getting the plane equation. 12x plus 3y minus 4 is equal to 65. That is r vector dot. This vector is 12i plus 3j minus 4k vector is a normal vector. Now writing a normal vector d vector equal to 12i vector plus 3j vector minus 4k vector is a normal vector. Now first find the direction cosines. Direction cosines of the normal vector. Now find the direction cosine. That is now writing the direction ratio. Direction ratios 12, 3, minus 4 is a direction ratio. Next find direction cosines. Direction cosines x by r, where r is a magnitude. That is a magnitude is modulus of d vector. Now find modulus of d vector equal to, modulus means square root of square the value. It is a square root of square is the value. 12 square is 144 plus 3 square is 9 plus 4 square is 16 minus 4 square is plus 16. Now add the value 16 plus 9 25 plus 144 root of 169 equal to 13. Root 169 value is 13. Modulus of d vector is 13. Now find the direction cosines. That is the direction cosines is This is direction cosines is formula x by r, y by r and z by r. Come on. This is x by r, y by r and z by r. That is x value, x is 12, y value 3 and z value minus 4 and r value is the magnitude, that is 13, r is 13. Now substitute the value, that is the direction cosines 12 by 13, y value 3 by 13 and z value minus 4 by 13 is a direction cosines. Next find vector form of, find the parametric form of vector equation. Now write in the vector form, this is a parametric of vector equation. Now write in the vector form is r vector dot d cap equal to p. R vector dot d cap equal to p. Already d cap is a unit normal vector. Already normal vector is given. Normal vector is 12i plus 3j minus 4k is a normal. Now write in r vector dot d. Already you know d cap is d vector by modulus of d vector. D vector is 12i vector plus 3j vector minus 4k vector by modulus of d vector. Already modulus of d vector equal to 13. 13 equal to 65. That is r vector dot 12i vector plus 3j vector minus 4k vector divided by 13 equal to 65 is a parametric form of vector equation. Next find the length of perpendicular to the plane from the origin. Next the length of perpendicular to the plane. The length of perpendicular to the plane from the origin. Already you know formula. The length of perpendicular from the origin to the plane is p by modulus of d vector. P by modulus of d vector. Here p value is, here p equal to 65. Here p value 65 and d value is modulus of d vector. Modulus of d vector value is 13. 65 by 13. Now cancel the value 13, 5 times. 5 13s are 65. That is the length of perpendicular to the plane from the origin is 5 units. That is 5 units. The length is 5 units. Next one, third problem. Find the vector and the Cartesian equation. The plane passing through the point with the position vector 2i vector plus 6j vector plus 3k vector, and normal to the vector I vector plus 3j plus 5k vector. Find the vector and the Cartesian equation. The plane passing through one point and one normal vector. Already you know one point and one normal vector is given. Vector form is vector equation is r vector dot n vector r vector dot n vector equal to a vector dot n vector. That is a one point and a normal vector is given. That is one point and one normal. That is a plane. Given one point is a vector. This a vector is small a vector, and the point let p be r vector, and one normal vector is n vector. One point and one normal vector is given. That is a vector form. R vector dot n vector equal to a vector dot n vector. Here the point a vector is the position vector a vector equal to 2i vector plus 6j vector plus 3k vector is a vector, and normal to the vector is normal to the vector n vector. N vector is normal vector. I vector plus 3j vector plus 5k vector is a normal vector. Now find the vector and the vector form. Find the vector form. Vector form r vector dot n vector equal to a vector dot n vector. R vector dot n vector equal to a vector dot n vector is the vector equation. That is now substitute the value r vector dot. Here n vector is this one I vector plus 3j vector plus 5k vector equal to, here a vector is 2i vector plus 6j vector plus 3k vector dot n vector is I vector plus 3j vector plus 5k vector. R vector dot n vector equal to a vector dot n vector. Write in r vector dot I vector plus 3j vector plus 5k vector equal. Now dot product of two vectors. Dot product of two vectors. 2 into 1 2. Next one 6 into 3 6 into 3 18 plus 18. Next one plus into plus plus 3 5s are 15. 3 5s are 15. That is r vector dot I vector plus 3j vector plus 5k vector equal to 18 plus 2 20 20 plus 15 35. That is a vector equation. Vector equation of the plane. Next find Cartesian equation of the plane. Cartesian form is let r vector equal to xi plus yj plus zk. Now substitute this one r vector. Write in a Cartesian form. Cartesian form. Cartesian form. R vector dot I vector plus 3j vector plus 5k vector equal to 35. Now substitute in r vector equal to, let r vector equal to xi vector plus yj vector plus zk vector. Substitute in this one. Xi vector plus yj vector plus zk vector dot I vector plus 3j vector plus 5k vector equal to 35. Now multiply 1 into x or x plus 3 into y 3y, 5 into z 5z equal to 35 is a Cartesian equation of a plane. It is a Cartesian equation of the plane. And this one is vector equation of a plane, and this one is Cartesian equation of a plane. And next, fourth problem. A plane passes through the point minus 1, 1, 2 under the normal to the plane of magnitude 3 root 3. Makes equal acute angles with the coordinate axis. Find the equation of the plane. A plane passes through the point minus 1, 1, 2 under the normal to the plane. Under the normal to the plane of magnitude 3 root 3 makes equal acute angle with the coordinate axis respectively. Find the equation of the plane. Now find the equation of the plane given one point that is passes through the point and normal to the plane. Now find the normal vector. Passes through a one point and normal to the vector. Equation of the plane is r vector dot n vector equal to a vector dot n vector. Now consider the equation of the plane is r vector dot n vector equal to a vector dot n vector. Given the normal vector is normal to the plane of the magnitude 3 root 3. Normal to the plane of magnitude 3 root 3 makes equal acute angle with the coordinate axis. Given the normal vector is makes equal acute angles with the coordinate axis. Next one given that is a normal vector of magnitude is 3 root 3. 3 root 3. Now find the equation of the plane. Now consider the equation of the plane is equation of the plane is the form is r vector dot n vector equal to a vector dot n vector. R vector dot n vector, where n vector is the normal vector. R vector dot n vector equal to a vector dot n vector. Here the point a vector is that is the passes through the points. That a vector equal to minus I vector plus j vector plus 2k vector. That's 2k vector that passes through the point. Now find the normal vector. That is n vector equal to n vector is now let n vector is li vector plus mj vector plus nk vector. Let normal vector is li vector plus mj vector plus nk vector. The normal vector makes equal acute angle with the coordinate axis. Make equal angle, that is here L value, here L equal to cos alpha, M is cos beta and N is cos gamma. L equal to cos alpha, L equal to cos alpha, M equal to cos beta and N equal to cos gamma. L value cos alpha, M value cos beta and N equal to cos gamma. Substituting this one, that is cos of alpha I vector plus cos beta j vector plus cos gamma k vector. Here the normal vector makes equal acute angle with the coordinate axis. Therefore the angles are equal. So given the angles are equal means alpha equal to beta equal to gamma. Angles are equal. Alpha equal to beta equal to gamma. Angles are equal. Now substituting this one, cos alpha, cos beta and cos gamma. So sum of the direction cosines. The sum of the direction cosines is sum of direction cosines equal to 1. Therefore cos square alpha plus cos square beta plus cos square gamma value equal to 1. Cos square alpha, cos square beta plus cos square gamma equal to 1. Given the normal vector make equal acute angles, alpha equal to beta equal to gamma are equal angles. Now substituting cos alpha, cos square alpha and beta values is alpha and gamma values is alpha. It is cos square alpha plus cos square alpha plus cos square alpha. Now writing cos square alpha plus cos square alpha plus cos square alpha equal to 1. Cos square alpha plus cos square alpha plus cos square alpha is 3 cos square alpha. Now write in 3 cos square alpha equal to 1. Cos square alpha equal to 1 by 3. 3 that side, divide by 3. Cos square alpha equal to 1 by 3. Now write in cos alpha. Now square root on both sides. Square and root are cancelled. Cos alpha equal to 1 by root 3. That is cos alpha equal to 1 by root 3. Cos alpha equal to 1 by 3. Cos beta values is 1 by 3. And cos gamma is 1 by 3. Now substitute in n vector. N vector is cos, here alpha value 1 by root 3. Cos 1 by root 3 I vector plus cos alpha values is 1 by root 3. 1 by root 3 I vector, 1 by root 3 j vector and 1 by root 3 k vector. Here n vector equal to, already cos alpha equal to 1 by root 3, substitute in n vector, li vector, cos alpha I vector, cos beta j vector, cos gamma j vector, cos alpha value 1 by root 3, or substituting 1 by root 3 I vector plus cos beta 1 by root 3 j vector, and cos gamma value 1 by root 3 k vector. And this 1 by root 3 is common, taking outside 1 by root 3 into I vector plus j vector plus k vector, that is n vector. The normal vector is the normal to the plane of the magnitude is 3 root 3. The normal vector to the plane of the magnitude is 3 root 3, that is n vector equal to 3 root 3 times of modulus of n vector or n vector. 3 root 3 times of n vector, that is n vector is 3 root 3 into, here n vector is 1 by root 3 times of I vector plus j vector plus k vector. Now root 3's are cancelled. 3 times of I plus j plus k multiply. This n vector equal to 3i vector plus 3j vector plus 3k vector. Here n vector equal to 3i vector plus 3j vector plus 3k vector. Now find the equation of the plane. Now find the equation of the plane is given already, one point passes through the point is given, and the normal vector is n vector is given. Therefore the equation of the plane, therefore the equation of the plane passes through the point, here A is already, A vector is passes through the point with the position vector, A vector is given. A vector already, right? A vector is minus I vector plus j vector plus 2k vector, and the normal vector is 3i vector plus 3j vector plus 3k vector, and the normal vector n vector equal to, n vector is 3i vector plus 3j vector plus 3k vector. Now find the equation of the plane is, equation of the plane in form is r vector dot n vector equal to a vector dot n vector. That is r vector dot n vector value 3i plus 3j 3k, 3i vector plus 3j vector plus 3k vector equal to a vector dot n vector. Here a vector is minus I vector plus j vector plus k vector plus 2k vector plus 2k vector dot n vector is 3i vector plus 3j vector plus 3k vector. Now multiply r vector dot 3i vector plus 3j vector plus 3k vector equal to 1 into 3, 1 into minus 3, minus 3. Next one, 3 1s are 3 plus 3 2s are 6. So cancel the value, plus 3 minus 3s are cancelled. That is r vector dot 3i plus 3j plus 3k. Let r vector equal to xi plus yj zk. Let r vector equal to xi vector plus yj vector plus zk vector. Now substitute xi vector plus yj vector plus zk vector dot 3i vector plus 3j vector plus 3k vector equal to 6. Now multiply 3 into x are 3x plus 3y plus 3z equal to 6. I dot I value 1, 3 into x is 3x plus 3y plus 3z equal to 6. Taking 3 is common, taking outside 3 times of x plus y plus z equal to 6. Therefore x plus y plus z equal to 6 by 3. Now cancel the value. 6 by 3 is 2. Therefore the equation of the plane is x plus y plus z equal to 2 is the required equation of the plane. Next one, fifth problem. Find the intercept cut off by the plane r vector dot 6i vector plus 4j vector minus 3k vector equal to 12 on the coordinate axis. Find the intercept cut off by the plane, that is a equation of the plane, cut off the plane on the coordinate axis. Already you know intercept form is in lower section level. This is x and y axis. The line is intercept the x and y axis. The intercept form is x by a plus y by b equal to 1. X and y, the intercept the line is x and x axis and y axis, x by a plus y by b equal to 1. Now find the intercept, the coordinate axis, x, y and z. X, y and z, that is x axis, y axis and z axis. Find the intercept of cut of the plane on the coordinate axis. That is a coordinate axis is x axis, y axis and z, that is a plane. Now intercept form is x by a plus y by b equal to z by c equal to 1 is the intercept form with the coordinate axis. X by a plus y by b equal to z by c equal to 1 is the intercept form. Where is the intercept of x intercept is a and y intercept b, z intercept is c. That is the intercept. Given, find the intercept cut off the plane, that is the equation of the plane is this one. Write in the equation of the plane. Equation of the plane r vector dot 6i vector plus 4j vector minus 3k vector equal to 12, that is the equation of the plane in vector form. Now write in the equation of plane Cartesian form is let r vector equal to xi plus yj plus zk vector. Now substitute in xi plus yj. Now multiply of, that is a 6x plus 4y plus minus 3z equal to 12 is a plane equation in Cartesian form. The plane is intercept the coordinate axis is, the plane is intercept the coordinate axis, x axis, y axis and z axis, x by a plus y by b plus z by c equal to 1 is the intercept form. Now this plane equation is divided by 12. This equation is divided by 12. 6x by 12 plus 4y by 12 minus 3z by 12 equal to 12 by 12. The equation is divide by 12, both sides divide by 12. Now cancel the value, 2 6 are 12, 1 6 are 6, 2 6 12. x1 1 4 are 4, 3 4 are 12. x1 1 3 are 3, 4 3 are 12, 12 12 are cancelled, remaining by 1. That is the form is x by 2 plus y by 3 plus z by minus 4. Z by minus 4. Plus and minus is minus. That is equal to 1. X by 2 plus y by 3 plus z by minus 4 equal to 1 is x by a plus y by b plus z by c equal to 1. That is a intercept form of the coordinate axis. Therefore the intercepts are the ratio. Intercepts are 2, 3, minus 4. That is a x-intercept is 2, y-intercept 3 and z-intercept is minus 4. Therefore, the intercept 2, 3, minus 4. Sixth problem. Problem 6. If a plane meets the coordinate axis at a, b, c such that the centroid of the triangle ABC is the point u, v, w, find the equation of the plane. If a plane meets the coordinate axis at the point ABC such that the centroid of the triangle is u, v, w, find the equation of the plane. First one, now write in here intercept form. This is x, y, z plane. X, y and z plane. The plane is intercept the coordinate axis. The intercept the point is A. Here the point is A. Here the point is B. Here the point is C. That is a plane. Now find the coordinate of A is, therefore the coordinate of A is A, 0, 0. The coordinate of B is 0, B, 0. The coordinate of C is 0, 0, C is the coordinate of C. Now find the centroid of the triangle is, already you know, centroid of the triangle is A plus B plus C. That is the point is A plus 0 by 3. That is a by 3. Next one, the centroid of the triangle, this one is B by 3 and this one is C by 3. The points are A by 3, B by 3 and C by 3. First, now write in a intercept form. Let the equation of the plane in intercept form is x by a plus y by b plus z by c equal to 1. That is let the equation of the plane. Now find the equation of the plane. Let the equation of the plane is x by a plus y by b plus z by c equal to 1. Let us assume the equation of the plane. Next one, the plane is intercept. The coordinate of a, b, c are. Therefore, the coordinates of a, b and c are. That is the point A is a, 0, 0 and 0, b, 0. A, 0, 0, 0, b, 0 and 0, 0, c respectively. The coordinate of A, B, C are A, 0, 0 and the point B is 0, b, 0 and the point C is 0, 0, c respectively. So the centroid of the triangle is, therefore the centroid of the triangle and the triangle ABC equal to, the first one point is A plus 0 by 3, that is A by 3. Next one, the point B is 0 plus B plus 0 by 3 is B by 3. And third one, 0 plus C by 3 is C by 3. Therefore, the centroid of the triangle ABC is A by 3, B by 3 and C by 3. Given the question is, the centroid of the triangle ABC is, the point is UVW. Given the centroid of the triangle ABC is UVW. So, that is implies A by 3, B by 3, C by 3 equal to U, V and W. Now equating x, y, z. That is A by 3 equal to 3U. A by 3 equal to U. Therefore, A equal to 3U. And next one, B equal to 3B. And C equal to 3W. A value 3U, B value 3B, C value 3W. Substitute in this equation. That is the equation of the plane is x by A. Here A value 3U plus y by B. Here B value 3B plus Z by C value 3W equal to 1. Therefore, the required equation, that is this equation is x by U plus y by V plus Z by W equal to 3. That is x by U plus y by V plus Z by W equal to 3 is required equation of the plane. That is x by U plus y by V plus Z by W equal to 3 is the required equation of the plane.